हेलो एवरीवन, वेलकम टू माय यूट्यूब चैनल डिबग टुगेदर। आज हम लोग देखने वाले हैं बाइनरी ट्री का बहुत ही इंपॉर्टेंट कॉन्सेप्ट, दैट इज लोवेस्ट कॉमन एंसेस्टर ऑफ ए टू नोड्स इन अ बाइनरी ट्री। ओके, बिफोर अंडरस्टैंडिंग लोवेस्ट कॉमन एंसेस्टर, लेट्स अंडरस्टैंड व्हाट आर द एंसेस्टर्स ऑफ एनी नोड इन अ बाइनरी ट्री। So basically the ancestors of any node in a binary tree will be its parent to parent, basically all the nodes from that node to the root node. Let's take an example of 3. The ancestors of 3 will be 1 and 0. But suppose we are also given that a node can also be an ancestor of himself. Okay, so now the ancestors of 3 will be 3, 1 and 0. Let's take another example. Let's take an example of 9. The ancestors of 9 will be 9 because a node is also ancestor of himself. 4, 1 and 0. Okay, now we understood what all the ancestors of any node. Let's understand what is the lowest common ancestor. So lowest common ancestor of two nodes, let's say we are given two nodes P and Q, will be the deepest level node which has both P and Q as its descendants. Okay, let's take an example. Let's take an example here. Let's say we are trying to find LCA of 3 and 9. Okay, what are the ancestors of 3? Ancestors of 3, basically 3. A node is also ancestor of himself. 1 and 0. What are the ancestors of 9? 9, 4, 1 and 0. So now here, as you can see, 1 is also a common ancestor, 0 is also a common ancestor. But what is lowest common ancestor? Lowest common ancestor is 1 because it is at deepest level than 0. So 1 is our LCA. So LCA of 3 and 9 is 1. Okay, let's take another example. Let's take one more example. Okay, let's take example of LCA of 6 and 5. Okay, so basically this is 6 and this is 5. What all the ancestors of 5? Ancestors of 5 are 5 and 0. What are the ancestors of 6? 6, 4, 1 and 0. Here only 0 is the common ancestor between 6 and 5. So this will be our LCA. Okay, here LCA is 6. Let's take one more example. Let's say we are trying to find LCA of 4 and 9. Okay, so what are the ancestors of 9? That is 9, 4, 1 and 0. Okay, what are the ancestors of 4? That is 4, 1 and 0. Here 4, 1 and 0, these are the common ancestor between 4 and 9. So but what is the lowest common ancestor? Lowest common ancestor is 4 because it is at deepest level. So LCA of 4 and 9 is 4. Okay, now okay, so basically whenever, let's say we are given two nodes, this was P, this is Q. Whenever one of the given node is descendant of another given node, let's say, because here P was given 4, Q was given 9, Q was descendant of P itself. In this case, one of the node is going to be the LCA. Let's take one similar example. This is important. Let's take one similar example. Okay, let's take example of let's say 1 and 0, 1 and 9. Okay, in this case, what are the ancestors of 9? 9, 4, 1 and 0. What are the ancestors of 1? That is 1 and 0. Here again, as you can see, this was, let's say, P, this was, let's say, Q. Here Q is all itself is a descendant of P. In this case, the answer is going to be one of the node, that is here P, that is basically 1. So LCA of 1 and 9, that is going to be 1. Okay, now let's see how we are going to solve it. Okay, so जब भी कोई ट्री का सवाल आता है ना यार, सबसे पहले हमें लगता है कि यार रिकर्जन लगाओ सॉल्व हो जाएगा. सेम यहाँ पे भी होगा, कोई भी ट्री का सवाल रिकर्जन से सॉल्व हो सकता है. ओके, सो व्हाट विल डू, विल अप्लाई रिकर्जन DFS, we will apply DFS, top down DFS. Before going to the approach, let's understand the intuition. Okay, so basically on high level, all the example which we have seen, there are only two high level cases. What are? One case one was, let's say this is the node, this is, let's say, root node of one of the subtree. Then in its left we found P, or and in the right we found Q. Okay, in this case the answer is always is going to be the this node, root node basically. Okay, now case 2, case 2, let's write it down here. Case 2, let's say this is P, and it either in its left or in its right subtree we found Q. Then in this case one of the given node is going to be the LCA. Here this is LCA, here this is LCA. These are only two high level cases which we need to apply and will solve it. Okay, let's take an example. Let's the first example which we have taken, that was 3 and 9. Okay, we'll start from here. Okay, we'll go to its left, we'll go to its left. As soon as we found one of the node, okay, let's say we are trying to find LCA of 3 and 9. As soon as we found one of the node, what we'll do, we will just return that node from there. Okay, that is going to be 3. That is basically case 2. We do not need to search for Q. Either Q could be there or Q could be anywhere else. But even if Q is going to be in its descendant, we do not need to search for it. Like in case 2, we just return P, right? So here what we'll do, we'll just return P, 3. Now from here we'll go to its right, we'll go to its left. Here we didn't find anything, we will just return null. For 4 we go to 9. As soon as we found Q, now we found Q. Again what we'll do, this is again case 2, this is again case 2, right? We'll just return 9 from here. It doesn't matter the order, which is P, which is Q. If you high level just see that this is, we found a node P, they say if this is Q, then P might be somewhere, but we do not need to search for it. Okay, we will just return 9 from here. Okay, now for the guy 4, from the left side we are seeing null, from the right side we are seeing 9. So what will be the LCA? We will just return a not null value here, we will just return 9. Okay, now for the guy 1, this is case 1. Now from the left side we found not null value, that means we either found P there, we either found Q there, right? Once we find not null value, that means this is either we found P, either Q, because we are only returning that node once we found that node. Okay, same from the right, we are seeing not null value, that is 9. Okay, again why we got not null value? That means we found a node which we are looking for. Okay, In this case, what is the LCA? In this case, this will be the LCA. So we will return 1 from here now. In this case, what we are going to return? In this case, like case 1, here we are going to return that this root node. Now 1. From here we will go to left, right, where we will go to right. From here we will return null. We will return null. 1 and null. What will return? 1. This is our LCA. Okay. Let's take one more example. Let's take one more. Not understood? That's okay. Let's take one more example now. Let's say we are trying to find LCA of, let's say, 1 and 8. Okay. Now from here we'll go to 1 left. As soon as we found one of the node, we won't go further from there. We won't go even left. We won't even go to right. We will just return 1 from here. Here we'll go to right. Now we found 8. Again, though we do not have anything here, but we do not even go search for it, right? We will just return 8 from here. Okay. Now here nothing else on the left side, that means the left side is null. From here we will return 8. Again, this is 1. From the left side we got the not null value, from the right side we got the not null value. We will just return 0. 0 is going to be the LCA. This is case 1. Again, we found P on the left, Q on the right. We will just return LCA, which will be the root node. Let's take one more example. Let's take the example where either P or Q is going to be the descendants of its another node. Okay. Let's say we are trying to find LCA of 1 and 9. Okay. Now from this is the root node. We'll go to left. Now we found 1. As I mentioned, once we found, this is case 2, once we found that node, now even Q is somewhere down the line, somewhere is as its descendant. We do not go and need to search for it, right? Because even if 9 is basically descendant of 1, LC is going to be the 1, because what we are doing top down DFS. That means this is the first node we found. We do not go to search for another node. We'll just return 1 from here. Okay. We do not go search for left, no search for right. We'll go 5, we'll go 8. Okay. Now we do not find anything. We will return null. And what will be the answer? 1. What is LCA? 1. See? Okay. Let's write it down, the approach. Let's say we are trying to find LCA of root P and Q. First write the base case. What is base case? If root is equal to null, or root is equal to P, or root is equal to Q, what will do? We will return root. This will be our base case. Now what we'll do? We'll find left. We'll do the recursion. We'll do LCA root dot left P and Q. We'll find the right, that is LCA root dot right P and Q. Now cases Okay, if left is also not null and right is also not null, in this case what will return? We will return root. Sorry, root. Another case, else if left not equal to null, then what will return? We will return wrapped. Else we will just run right. यही तो किया था हमने यहाँ पे. Let's try run this approach. Okay, let's try run. Let's take again, we are trying to find LC of 3 and 9. Okay, now this is root. So value will go left, will go left. We'll find our base case. We'll find our base case. So what we'll do? We will return 3 from here. Here will go right, will go left, and again will go left. Again we'll hit our base case. We'll return null from here. This will return again null from here. Okay, we'll go right. Again we will hit our base case. Here will, from here will return 9. From if, let's see, if left, now for the guy 4, left is null, right is not null, so we will hit this else case, right? Because left not equal to null, right not equal to, this is not going to meet the criteria. Here left not equal to null, no. Here right is basically not null, so we'll return 9 from here. For the guy 1, will hit our first case, this one, because left is also not null, right is also not null. In this case we will return 1 further. We will return 1 from here. Okay, similarly we will go here, we will hit null, we will return null, we will return null, we will return null. Now here what will be case? Here we are going to hit this case. For the guy 1 0, we will hit this else if case where left not equal to null. What will do? Will return null. Okay. Let's solve this problem. This is the lead code problem 236, lowest common ancestor of a binary tree. Read the description. It just wrote everything which we have mentioned. As the one of the point which I mentioned, that was a node to be descendant of himself. Same thing. A node is also ancestor of himself. A node is also a descendant of himself. Let's solve this problem. Let's solve it. Okay. If what was our base case? Let's write out down the base case. What was the base case? That was if root is equal to null, or root is equal to p, or root is equal to q. We will return root from here. Now we'll find left. That will be, let's copy this. That is root dot left p and q. Same, will find right, root dot right p and q. Now what were our cases? If left not equal to null and right not equal to null, in this case we will return root. Else if left not equal to null, in this case right either is going, it is, now this else if case is basically right is going to be the null, because if right is also not null, then we will meet the if criteria, right? In this case what we'll do? We'll return left. Else we will return right. This else is going to meet two criteria. In this case either left is not null and right is null, right is not null, either both left and right is null. In this case we'll basically meet all the 4 criteria. If both the values are null, if one of the value is null, if both the values are not. Let's run this code. Let's run this. Okay, let's run this. See, we'll not. Let's submit this. Okay, thank you. I think, yeah, this was I think this is very important concept, and lot of companies ask a problem directly related to LCA, or somewhere we might need to understand how LCA is going to be implemented. Okay, thank you.